So we need to solve one more problem of free oscillation. The problem looks weird to me, but I'm solving too many weird problems. So I'm going to solve it one more. And the statement of the problem being two loads of mass m, these are the loads, I guess, are suspended from a horizontal ceiling. Ceiling is horizontal. That's right. Ceiling is horizontal. By two weightless, inextensible threads of lengths L1 and L2. L1 and L2 is not same. Then something else will happen. Okay, let's see. The loads are connected by a light, rigid rod. Okay. In the equilibrium position, the threads are vertical. Okay. Determine the period of oscillation, a small oscillation of the system in the plane of the figure. And that means what? Okay. I will give it a try. But the very first thing is important to imagine what will happen at the next moment when I disturb this thing from its equilibrium position when the threads are vertical. It's going to look like this. Yeah. There is some change in height, and this whole length is x. It will be circular, of course, if you can think. And if this angle is alpha and this angle is beta, you can you have simply I have taken out this rigid rod, a length x in front of it, so that I can write here x is same for both, so I can write here alpha equals x by L1 and beta equals x by L2. These are two different angles, and since both has moved some height, and heights will be different, it has moved somewhat height y1. So y1, you would like to write this length is L1, so this whole length is L1 cos alpha. So this small length becomes L1 minus L1 cos alpha, and you would like to write it L1 1 minus cos alpha. And if I assumed alpha is small, so cos alpha is equal to 1, then everything vanishes. Nothing happened. So I need to take the second order approximation, and I can do it like this. I would like to write 1 minus cos alpha equal to sine square alpha by 2, and that will be 2 alpha square upon 4, that is will be equal to half alpha square. So y1 will become half alpha. Alpha is x by alpha 1. That means y1 will become half L1 x square by alpha 1 square. That means x square by 2 alpha 1 will be the value of y1. And so you can write y2 equal to x square by 2 alpha 2. And you can see the whole system has lifted, system of loads has been lifted upwards. So its gravitational potential energy has been increased, and it has been increased by an amount mg y1 plus y2, and that is simply mg y1 plus, I would like to write it mg by 2 1 by L1 plus 1 by L2 multiplied by x square. Do you like it or not? Okay, so this potential energy can be written as like this. Now I need to do something about its kinetic energy, so I would like to write their speeds. Suppose the velocity of the left ball, I would like to write it as v1, and v1 I can write dx by dt square plus dy1 by dt square. These are the things. X1 is practically horizontal, and what can I do after that? I can take out the dx by dt from outside the square root, so I can write it here as 1 plus dy1 by dx square. And I knew something. I knew a relation between y1 and x, and that was simply y1 equals x square by 2l1. So I can write y1 equals x square by 2l1. Okay, y1 equals x square by 2l1. So I would like to find dy1 upon dx as 1 by 2l1 2x, and that will be x by l1. Yeah. So v1 will be equal to dx by dt under root 1 plus x square by l1 square, and x is very much smaller than l1, so x square by l1 square will vanish. X by l1 square should be approximated to 0. That means v1 is equal to dx by dt, and so will be v2. So the kinetic energy of the whole system can be written as half m v1 square, that is dx by dt square half, that is half, let's say it v1 equal to v2 equal to v, so we can write it half mv square plus half mv square equal to mv square, and I can equate it with potential energy. That means I can use or I can write something like total mechanical energy of the system is kinetic energy plus potential energy, and kinetic energy is half mv square, and potential energy was something like this, mg by 2. Potential energy was something like mg by 2, 1 plus L1 plus 1 by L2 multiplied by x square. This is the total mechanical energy. If I differentiate it with respect to time, the mechanical energy is going to remain constant. So dE by dt will be equal to 0, and I can write something like m2v dv by dt plus mg by 2 1 by L1 plus 1 by L2 2x dx by dt equal to 0, and dx by dt is v, and this. So you can get your omega as the angular frequency of motion, simply as so m gets also cancelled out, and everything cancelled out, and I get simply g L1 omega square equal to g L1 plus L2 divided by 2 L1 L2. Yeah, 1 2 will remain here, 2 L1 L2. So time period will be equal to 2 pi under root 2 L1 L2 by g g L1 plus L2, and that's your answer. Thank you very much for watching, and okay, thank you very much.